Today we want to continue interpreting definite integrals. So I have a simplified version of the fundamental theorem of calculus, which says that the definite integral from a to b of f prime at x dx is f at b minus f at a. So remember that f prime of x we can also think of as the rate of change of f. Then the dx says with respect to x. And so over here on this side, we have the net change in f on the interval from a to b. This fits with what we know about the sign of the derivative and the direction of the function. So remember, sign of derivative tells us about the direction of the function. So if f prime of x is positive on the interval from a to b, that tells us that f of x is increasing on the interval from a to b. And so that means that f at b will be greater than f at a, and this difference will be positive. Oh, yeah. So what this means is that f of b will be greater than f of a, which is the same as saying f of b minus f of a will be greater than 0. The definite integral, so if f is increasing, if f prime is positive, then f is increasing. The definite integral tells you how much the function increased, tells you how much the function increased. If the derivative is negative on the interval, then f of x is decreasing on the interval. And what that would mean is that f of b is less than f of a. And that would mean that f of b minus f of a will be less than 0. Because we ended up at a value that is lower than when we started. That's what decreasing means. So it all matches together. If a derivative is positive, the function is increasing, the area tells you how much it increased. If the derivative is negative, then the function is decreasing, the area tells you how much the function decreased. So this matches up. If we look at the graph of f prime on the interval from a to b, this area is the definite integral. So the area tells you how much the function has changed. Any questions? So what we want to practice is looking at rates of change in some context and then calculate and read what the definite integral is telling us. So let's look at some rates of change in context and interpret some definite integrals. Let's consider some rates of change in context and interpret some definite integrals. So, for example, Let's suppose that I'm just going to steal this example because I always go for position, velocity, acceleration. So let's put that one aside and look at, well, secretly just a different velocity. Let's suppose that pollution is removed from a lake at a rate of f of t. Now, this is going to be a rate of change. So f of t kilograms per day. Oops, spelled y wrong. F of t kilograms per day at t days after starting the pollution removal program. Let's make it a machine. That way all the tech people will say, oh yeah, we'll build a machine that'll remove all the pollution. That way we could just keep putting pollution in and not worrying about it. So f of t is the rate of change of the pollution as it's being removed from this lake at t days after we start up our pollution removal machine. So f of t is kilograms per day. So if I have a value, if I have something like f of 12 is equal to 500, f is the rate of change of the pollution removal. So the 12 means 12 days after we started our pollution removal machine, and the 500 represents the rate at which we are removing pollution. So we could say 12 days after starting our pollution removal machine, known as a PMR. That's what we were calling it, because we're cool and we have to abbreviate everything. 12 days after starting the pollution removal machine, we are removing pollution is being removed from a lake at 500 kilograms per day. Let's say is being removed at a rate of 500 kilograms per day. The function is telling you how fast things are going. The function is the pollution removal speedometer. So the F of t is the pollution removal speedometer. It's telling us how fast the pollution is coming out. So it's a rate of change. It's measured in kilograms per day. Now this is what the statement about the function means. Let's look at a statement about the definite integral. Same example as before, same function. If we write the definite integral from 5 to 15 of f of t dt equals, let's say, 4,000. Now we're integrating the rate of change of pollution. So this will give us the net change in the amount of pollution. So the definite integral of a rate of change That's the rate of change of pollution. The definite integral of a rate of change will give us the net change in the function. So this is in kilograms per day. This will give us the net change in the pollution. And this will be just in kilograms. Remember what we're thinking about integration. We're thinking that integration is multiplication in which one of the factors is variable. We're not pulling pollution out of the lake at a constant rate, so we have to integrate the rate at which pollution is being pulled out of the lake. The dt is the change in time. We're evaluating the function at say 5 days, and we're multiplying it by some small change in time. So the dt is the amount of time. So we could think of the kilograms per day multiplied by days will just give us kilograms. So that's kind of what's happening. If we think of that dt there representing days. We have kilograms per day. I spelled day wrong. And we multiply by the number of days. That will result in kilograms. The unit analysis says so. Kilograms per day multiplied by days will give us kilograms, as we can calculate the days. Or sorry, we can cancel the days. The other piece of information that's running around in this definite integral is the interval over which we are integrating. So this is the interval from 5 days to 15 days. This is t goes from 5 days to 15 days. So we need to cite that as well. Since the definite integral is going from 5 to 15, we're saying between day 5 and day 15, between day 5 and day 15, 4,000 kilograms of pollution have been removed from the lake. Between day 5 and day 15, that's the definite integral parts, we integrate the rate of change of pollution between day 5 and 15. That'll give us the net change in pollution from day 5 to day 15. So between day 5 and day 15, 4,000 kilograms of pollution have been removed from the lake. That's the net change that has been removed from the lake. Any questions? So let's pause the video here and then do some more examples.